Assalamualaikum and good day. So we are from Group 7 from S14 of Foundation in Science that's studying in Center of Foundation Studies, Foundation Physics 2. So we are going to present our lab report for our second experiment, which is Ohm's law. And our lab instructor is Professor Madhya Dr. Muhammad Azham Abdul Rahman. Our team consists of me, Izzatul Najihah binti Azham, Nur Afifah binti Zahri, and Nur Ain Syafiqah binti Muhammad Zahid.
For the introduction, we would like to explain that electric charge is the electric current that is flowing from one place to another. So in this case, a potential difference is required to produce an electric current. The electric current in a metal wire is proportional to the potential energy applied. Wires also present some resistance to the motion of electrons under normal circumstances. Thus, this proves that electric current in wires not only depends on the potential difference, but it also the resistance of the wires. In Ohm's law, we also can determine the resistance in the circuit, and also we can define as the voltage increase, the electric current also increase. Moving on to the theory, Ohm's law was discovered in 1872 by a scientist named George Simon Ohm. He states that resistance of a wire is a constant independent of voltage. Thus, the amount of electric current through a metal conductor in a circuit is directly proportional to the voltage across it. As we can see in this 1.1 equation, I is directly proportional to the V. So when we plot a graph which is I versus V, we can get a linear line. That's proof that R is independent of V, and through the graph we also can define Ohm's law as V equal to IR as shown in equation 1.2. The objective of this experiment is to justify Ohm's law. The apparatus that we use in this experiment is voltmeter, ammeter, connecting wires, switch, power supply, resistor, rheostat, and graph paper. Moving on to the methodology, as we can see in this figure 1.1 is the sketch circuit. Firstly, we can see the power supply and also switch, and then rheostat followed by resistor and voltmeter and also ammeter. So there are several steps that we need to follow to do the experiment. Firstly, the circuit was set up using 50 cm wire as shown as figure 1.1, and then the power supply was switched on. Rheostat was adjusted to produce 10 voltage on the voltmeter. So the resulting current was recorded in the table 1.1 as indicated on the ammeter. So this experiment was repeated again with 20 voltage, 30 voltage, 40 voltage, and also 50 voltage. All the readings, which is resulting current, were recorded in the table 1.1.
Next, moving on to data and analysis, we are going to tabulate the data that were achieved from the experiment as shown. And after that, we are going to use this data to plot the graph of I current versus V voltage. And from this graph, we can obtain a linear line, which is the M. And after that, we can calculate the slope of the graph, which is M equals to 1.0 times 10 with the power of negative 4 with the unit of ohms with the power of negative 1. And after that, to calculate the error, we can draw two other lines, which is M1 and M2, and then calculate their slopes. And given in the graph as shown, we found out that M1, the slope for the line, the first other line, is 1.2 times 10 with the power of negative 4 with the same unit of m. And for m2, we get the slope, which is 8.6 times with 10 with the power of negative 5 with the same unit as m2. Error, which is 1.7 times 10 with the power of negative 5 ohms with the power of negative 1. So from Ohm's law, we can get the equation which is V equals to IR. And R, we can find it by putting I to the other side, which is R equals to V per I. And from the graph, slope is I per V, the graph that we sketched just now. And therefore, slope means 1 over R. So to find the R, which means that it is 1 over slope. So the R resistance is 1 over slope, whereby 1 over 1.0 times 10 with the power of negative 4 and we will get the R, which is 1 times 10 with the power of 5 ohms. So with calculated errors, we can conclude that R is 1 times 10 with the power of 5, which is 1000 ohm, with a plus minus of 1.7 times 10 with the power of negative 5 ohm.
Discussion. As can be observed from the data above, Ohm's law can be rectified by using a simple circuit. Based on the graph current versus voltage, we can form a linear line which shows the current is directly proportional with the voltage value. From the data, we can obtain that the higher the amount of voltage applied, the higher the amount of current will produce. For resistance, we can predict it by using equation V equal to IR and derive it to R equal to 1 over slope. We calculate the value of slope on the graph and substitute it in the equation. And the value of resistance is 1.0 multiplied 10 to the power of 5 plus minus 1.7 multiplied 10 to the power of negative 5 ohm. In this experiment, the major source of error was a random mistake made by the instrument. However, this mistake was incredibly difficult to negate and this mistake did not produce the laboratory score message. It is not fair to buy new applications because our findings were very close to the actual value of our devices, as error is very minimal, which is just 1.7 multiplied 10 to the power of negative 5, smaller than 1.0. Moreover, another error that occurs was that of when the meter was not perpendicular to the eye level and thus caused a parallax error which disturbed the accuracy of the results. Overall, the experiment went well and it succeeded the purpose of the test, which was how changing the voltage could affect the amount of current flowing in a series circuit while being able to prove Ohm's law. Conclusion. To sum up, this experiment is considered as a success because the objective was able to be met, as Ohm's law is justified based on a linear graph of I versus V drawn. The higher the voltage, the higher the current, which proves that I is proportional to V. Plus, in a series circuit, the resistance is the same throughout the whole circuit. Therefore, resistance can be determined from the graph whereby R equal to 1 over slope SR acts as a constant in the Ohm's law equation, V equal to IR. This is the reference of our experiment.